Okay, hello everybody. This is the demonstration of how a transformer working, and this is a transformer, and I pulled out this from digital audio control center from Sony, and it's used to be right here. Whatever you can see, it's just right here, and this chip it's just basically like connected. Whenever this wire is connected to this chip and connect to this transformer, and for all the three other wires is for powering one of this chip and LED display and audio. Basically, I think it's just for audio tuning chip, and also like I trying to basically test this out, like see what the output voltage are, but whenever we can demonstrate here is if I output this and it doesn't give anything, it just doesn't give anything like really valuable information here. I think whenever I break it down, maybe I break something, or it just like something the chip won't work anymore because due to the time or something like that, and something maybe is broken. So but from the chip we can see is we have a protector here, and here is 125 volts. I think it basically what it does is just like this pin is connected to the one of the chip here. You can see. Excuse me. Sorry, sometimes it's hard to get it connected, but it's definitely yep, go. It should be working with this thing. So I think somehow it just not working at all for this one. I don't know why, but here's the thing: is this I pull out from here. So I think whatever this does is just like when the 110 volt or 112 volt, 60 hertz. That's whatever from the power supply come out and goes through the transformer, step up to 125 volts, and then this one I think is for the powering the chip. That's like a 64 volts, because those power supplies only can take, I think it's only can take like 64 volts. That's the maximum. So I imagine that maybe this one is for the 64 volts, will give a step down, and this one is for the LED. I didn't really see any label for the voltage here, but I'm assuming maybe no more than 15 volts. So it's kind of like this transformer doing a three job, like which is 1 for step up, 2 for step down, and okay, for this transformer, I just tell like how it works, but I was thinking like I can break down this thing, you know, like maybe I can just using the it's better I just show like how the transformer is actually like made of. This is kind of like this type of transformer only made of like for the cover here. If you take out the cover, and you can see it's all, since they have a coil inside, but the coil is just like, for example, that's the coil I make for just for demonstration. Here is because we don't have the iron like core inside of it, so we have like a coil here. That's the material. It's just I make it from plastic, and what the iron core does is just basically sit here, like this one. You can see it's just maybe like that. And the iron core was just doing like this way, and we have a cap here on the top. You can see it was like sealed up like that, and Yep, that's maybe and there is a cap here to hold it down. So whatever it does is just like doing this way, and then what this says is just like the coils go around the material like this way. I make this for demonstration experience. Like this one is you can see is a step up transformer, and this is just actually the step down transformer. I'm sorry about that. It was come from this was like a 20 row. I mean 20 turns. Sorry, 20 turns onto 5 turns. So if, for example, we have like a 4 volts per turn, and for the material, we can have like a that's 80 volts, and that'll be 20 volts. So 80 to 20 volts step down transformer. If I have a iron core here, the material of this thing, we can use any kind of like a material, plastic. It's better with probably like ceramic, and that's basically how the transformer gonna work. And this is basically a small demonstration, because I actually at first time I tried to break down this, but you can see it was sealed by this I don't know what kind of oil they use to seal this thing. And then whenever we try to iron this one like off, it only take off the skin of it, and the rest of it is like we need more heat to bring this down. So that's why, and also because of they were glued together, so we have to use like hammer or something like that to break it down also, which is not easy to do, and you might break out the iron core, because whenever this was layer by layer, and you break a layer, you probably don't be able to use it anymore. And I think that's it why I just do a demonstration instead of just making a transformer. And it's hard to get one of this matching the size of the iron core here. So, and that's it. That's basically it. And what the problem to bring up me to make a transformer is because in China there was like a step when I bought like a razor from American, when I brought to China, there was something wrong with the razor, because it's because of the transformer, it's because of the hertz. And in America there's 11 volt, and there's 60 hertz, but in China, even the transformer going to step up to 220 volts, but they cannot change the hertz to 50 hertz. So what I'm trying to do next is trying to maybe transform the hertz from 60 to 50.
Okay, here is one way to convert the 50 Hz to 60 Hz. First, we can get the 220 volt and the 50 Hz, and we can get the corn legends and corn whites. We can get a corn error, and we can use the formula equation to get the terms to peer voltage, and use the voltage to get the how much term. So we can get a 5 term and a 220 term. So from here, we can get a 5 and 15 Hz, and this one is LED for screen. And for here is keep going and until the here. This is the 5 timer. First, we just need to get the square wave, because when we get a 5 volts 50 Hz is a sine wave. So first we need to get a square wave for use the 5 timer. Here is the R1 and R2 and C1, and here is the output, and here's ground. So for this 5 timer, just change the signal for the square wave. So here we can get the 5 volt 50 Hz for square wave. So next we will talk about how to increase the frequency. Here is the next part. This is the last part. 5 timer is a square wave, just go in, and for this one, all part is the CD4528. This one is increase the frequency for the multi-stem. for different frequencies. First, we just come from here is A and B is separate, and separate is A and B is a logical from logical inside for the 4528, and when we give out, we can get the 5 volt 6 hertz the square wave. Yeah, this is a square wave, is not changed, but just change the frequency. And for last part, we just need to change the square wave to a sine wave. For this one, we can get the sine wave. This not changes frequency, just changes the signal, the shapes.
We basically just using a low pass filter for this.
Yeah, low pass filter. And when we get the 5 volt 6 hertz, we need to come back to the 110 volt, and we just need a transformer again. Here's the error. Here's the term for period volt. Here's a 5 volt to 5 term, 110 volt to 110 terms. And here is we just do the demo.
So this is whenever the 5.5 timer was feeding in a 4.86 of frequency sine wave here, and we have an output come out with a frequency of 48.4 hertz square wave. That's basically the first step we know, because the reason we didn't do the next step is because we didn't find this chip online. It was taking too long to shipping by the time we demonstrated this. So that's the way basically the rest of the steps for doing this, and also that's basically how we're gonna set up a whole whole stuff, like try to transfer the frequency and also doing a transformer with the whole system. All right, thank you for watching, and have a great day.